The admission fee at an amusement park is $2.25 for children and $4.80 for adults. On a certain day, 244 people entered the park, and the admission fees collected totaled $804. How many children and how many adults were admitted? Okay, so basically on this problem, we're going to have first a people equation, because we'll call the number of children C and the number of adults A. You can use X and Y, but I found it's easier to just use letters that are meaningful, like C for children, A for adults, rather than X and Y, because that way when you're done, you'll remember what they are. So we're gonna have a people equation first off, and that would be number of children plus number of adults equals 244, huh? Does that make sense? Just 244 total people. And then we're going to have a money equation. And so each child is 225. So it'd be 225 times C. Is that making sense right there? Because every child, C is the number of children that came to the park that day, and A is the number of adults. So every child costs $2.25, and then every adult is a 480. So 480 times A. That adds up to be the total amount of money. Oops, $804. Like that. Okay, so we have two letters, and so that makes sense that we need two equations, right? Two equations, two letters. So how do we solve two equations, two letters? Well, notice right here, the C and the A, there's just invisible ones in front of those. There's no number really in front of C or in front of A, which means it's really one. So that would mean it's easy to do the substitution method. So I'm going to do that. So step one, get C alone in the first equation. So I'm going to take that, the first equation, C plus A is 244, and I'm going to subtract the A from both sides. And I get C equals 244 minus A. So now I'm going to plug that in now to the second equation. Excuse me. Plug that into the second equation. So I'm going to take that, grab the second equation right here. Grab that second equation. Bring it down. 2.25 C, and then I'll grab the C right here. Plus 4.80A is 804. That makes sense. So I got C alone in the first equation, and then I plug that in for C to the second equation right there. That's C. Okay, now we're just going to solve this. So let's distribute, use your calculator. 2.25 times 244. I'm getting 549 minus 2.25A plus 4.80A is 804. And then that's, now we can just subtract 549 from both sides. Like that. And we can go minus 2.25 plus 4.8, that's 2.5 2.55a. So I just combine those two there. I don't know if that made any sense. I just take 4.80a, take away 2.25a. Just subtract that on your calculator. And 2.55a equals, and then subtract those two. I don't know what that is. 804 minus 549. Getting 255, that's convenient. And then divide by the 2.55. Boom, boom. A will equal, that's 100. So A is 100. So 100 adults. And now to find C, we can just plug into step 3. Plug A equals 100 in anywhere. Oops, it's a funny looking anywhere. Anywhere to find C. So you can just grab that first equation, which was C plus A equals 244. And you really could just subtract, right? Because the total number of people was 244, 100 adults. So subtract, got to be 144 kids. Probably the easiest thing is just subtract. But anyway, I'll do this more formal way. You plug in 100, then it's same thing, right? Ends up just subtracting the 100. So the C will equal 144 children. So 144 children, 100 adults. So how do we do it again then? We wrote, since we had two variables, children and adults, we knew we needed to have two equations. Two variables, two letters, always means two equations. The first one is just the total people. Children plus adults is 244 people. Second one's the money, 2.25 times children plus 4.80 for each adult is $804 total collected. And then to solve the two equations with two letters, get C alone in the first equation, plug that in for C right there. In the second equation, distribute, solve for A, and then plug that back in to get C. So there we go.